Good good afternoon. I promise that I'm going to show you how to do uh, proving two triangles similar, doing two-column proofs. Okay, so this will be, first column will be the statement that you're going to do, and then the second column will be the reason for that statement. Okay. As much as possible, when you do proving, you try to analyze uh, from the figure what is given. So here, uh, segment MO is parallel to PN. So I will make this marking here. That's parallel. And what is the implication of this given? Okay, so here I will have the step number one, MO parallel to PM. And my reason here is it's given. Okay, it's given. And number two, the implication of that will be that this angle here is congruent to that angle. So I say angle O is congruent to angle P. My reason to that will be uh, the two segments are parallel, so then the alternate interior angles should be congruent. Okay, take a note of this. It's not AIP. This AIP here means that if two angles are congruent, alternate interior angles are congruent, then the two lines are parallel. Here we are given that the lines are already parallel, so they form alternate interior angles that are congruent. Okay. Okay. Now I can have this one here also congruent to that for that same reason. Angle M is congruent to angle M. Parallel lines, then you will have alternate interior angles. I could just stop here now and say that letter A has been proven. But if you want to go ahead, I can say this one here, this angle is congruent to this angle. I will name this angle 1 and angle 2 so that we'll have a shorter statement. So we get here. Angle 1 is congruent to angle 2. You know that angle 1 is congruent to angle 2 because of what? Vertical angle theorem. Uh, okay, and then here, I have here an angle, and another angle. I can now say that triangle, look at the correspondence there. MOQ is similar to triangle NPQ by AAA, similarity theorem. Okay. If I did not have number 4, I only had two angles here shown, then I could have just said AA corollary. But I went ahead and identified the third congruent pairs. Okay, so this one has been proven. Now, letter B and letter C are actually the offshoots of this. If I am going to have this one here, if I have the proportional sides, MO over NP, and also MQ over NQ, and then OQ over PQ. This is because of what? Uh, Definition of similar triangles. What does it say? The sides are proportional. And let's see, can we get uh, an MQ and QP and OQ and NQ? Okay. For letter B here, we can actually now derive it from here. Okay, so step number 7 would be now MQ times PQ or QP equals what? OQ times NQ by MPE. Okay, MPE. We just cross multiply that. So we are done with that. What about the third one, letter C? We have here MQ and NP. MQ and NP. Okay. So it will be this pair of similarity of proportionality, I mean, here. If I apply, okay, number 8. If I apply MPE again, I will get here what? MQ times NP equals NQ times MO. Okay, for this is also MPE. Then I will end my proof by writing these two bars here. That means it is over. Okay, so let's see what we did. We relied on the given here, MO and PN. Okay, and then what are the implications of this given statement? We know that if segment MO is parallel to segment PN, it produces pairs of alternate interior angles congruent. So that's what we enumerated here. So, and then we were able now to conclude uh, we already have all the ingredients of two similar triangles, so we were able to have that. And the letter B and letter C are only offshoots of these two similar triangles. So when we know that the two triangles are already similar, we can have the proportionate sides written. Okay, and that's the reason there will be definition of similarity. Okay, so in any case, you just have to start with the given and then you work on the implications of the given. Okay? Let's have another number here. Uh, what about, okay, that will not be SAS lang yan. Okay. Okay, let's have number 5. It's a little similar to what we did. Okay, so what again is given? What is given here? We are given that, so the two columns, I write them here. Uh, this will be the statement, and then this will be the reason. Okay, again, we say that that given there, BE is parallel to AC. D is parallel to AC. Okay, that's given. Okay, you always have to work on the given. Now, what are the implications? If DE is parallel to AC, I'll make this marking here, DE is parallel to AC, you will notice that if two lines are parallel, again, these corresponding angles are congruent. Okay, so that will be what we say. Therefore, here in the drawing, this should be congruent to this one. And also, this angle will be congruent to this. And if I now try to separate the two triangles here, I said BDE, and the bigger triangle will be BAC. I know that this angle is congruent to itself, okay? And I already know that BDE, which is angle D here, is congruent to B angle BAC. So this one here is congruent to this one. So I now have two corresponding angles congruent, and I can already say that these triangles here are similar. But let me go on. Let me go on. um, I will have this third angle congruent to that angle, third angle. Okay, so let's write those what we have said there. Okay, so I can now say angle B is congruent to angle B. Okay, this is reflexivity. Reflexivity. Okay, and number three, angle D here in this triangle here, angle D is congruent to angle uh, A. Okay, I will just, this is parallel lines, corresponding angles are congruent. I will opt to say that triangle BDE is similar to triangle BAC. I will use here AA corollary. I just made use corollary. I just made use of two angles. Then from this similarity, I can have now the ratio of the sides. So BD is to BA as BE is to BC as DE is to AC. This one is my concept of proportionality. This is definition of similar triangles. Similar triangles. Now, let's see which of the proportions will give you this AB and BE. AB and okay. I already spotted it immediately. AB and BE here, this one here. Okay. And if I have that, I can just say what? AB times BE equals BD times BC. This is by MTE. And again, we are done with this. So that's it. Okay. So there are two illustrations now that I have done for you. Okay.